Right guys, let's have a look at 4 then. We've got y equals 2x squared minus 3x cubed. So let's get dy dx gradient function. Differentiate this then. Be 4x to the 1 to minus 9x squared. We let that equal 0. Now we look at this here. When does that equal 0? We need to factorize, don't we? So we're going to x common. So let's take that outside the bracket. And then we'll have 2 terms inside, so we draw the 2 lines. So what goes here? Well, what times x gives 4x is 4. Yeah, 4x will give that one. And then here we'll need a minus 9x, won't we? Because that will then make minus 9x squared. Yeah? So that product is 0. When does that product equal 0? Well, it equals 0 when either this is 0 or when this is 0. So when does this equal 0? Well, simply it happens when x has the value 0, doesn't it? When does this equal 0? Well, 4 minus 9x. When does that equal 0? Well, move the 9x over, keep the 4 it is. Move the 9x over and flip the sign through the equals. Divide by 9 both sides now. So let's just do that here. And read from right to left. And we can write it down as x equals 4/9, can't we? So there we are. There's our 2 turning points. So there's the inputs. Now we need the outputs. So the first one at x equals 0 then. What does y equal? Well, it's 2x squared minus 3x cubed, isn't it? So let's just overwrite the x. Wherever we've seen x, we put a 0. Okay, a little bracket, and a 0 goes there. So 2 times 0 squared minus 3 times 0 cubed. That's 0 and that's 0. So you get 0. Right? Now the other input value at x equals what was it? 4/9. So we're going to need our calculator for this, aren't we? Y equals, it was 2x squared minus 3x cubed. Wherever we see an x, I'll put a little bracket and we want to overwrite that with our input value of 4/9. So I'll just overwrite it because that's the easiest way to do it, isn't it? So that's what we've got to put in the calculator then. Let's just do that then. So it's going to be 2 times bracket 4/9 fraction, so it's 4 toggle to 9, toggle back up to ground level, put the bracket, and then it's squared. And then we're on ground level, so I can just write minus 3 times, and then bracket, fraction, 4/9. 4 toggle down to 9, close bracket, power. Oh, now I've got that wrong, haven't I? So I better delete that. Delete that. I needed to toggle out of the underneath. Close the bracket and put a power and put cubed. Toggle back to ground level. And that's it. So it's 2 times this squared, yeah? Minus 3 times 4/9 cubed. There we are. Press the equals. What do we get? Let's go for the decimal. 0.13. So it's positive, so y equals 0.13. Agreed? Okay, let's just double check that, make sure we haven't made a mistake. Yeah, it's 2dp, 2 times that squared minus 3 times that cubed. Everything seems okay. Good. Right, so there's our input outputs then. So you can mark them off on a diagram. So let's do a little sketch here. The first input is 0, and at 0 the output is 0, so the height would be 0. That's the output, here's the input. Yeah, the second value was when x was 4/9, so we can put it here. There's the input 4/9, and the output was just a smidge up, wasn't it? And that was 0.13, that height. And this is 4/9. Yeah. Okay, so we've got these 2 turning points. We don't know which one's which. We don't know whether it's a maximum or a minimum, so I can draw the 2 possibilities in here. Now we'll need to work out the second derivative. So I'll put that up here. d2y by dx squared then. Let's work out that. Differentiate dy dx, yeah? So 4x goes to 4 times 1 minus 18x, yeah? Now what does that equal then? So it's 4 minus 18x, 4 minus 18x, okay? The input is 0, so if I put 0 here, 4 minus 18 times 0, 18 times 0 is 0, 4 take 0 is 4, which is positive, so it's a min, yeah? So that one's a min. So when x is 0, here we have a minimum. So I can draw that in more firmly now. And this one, when x was 4/9, so I can put 4/9 in here. 4/9. And 18/9 is 2. 2 times 4 is 8. 4 take 8 is -4, which is negative. So if it's negative, it's a max, isn't it? There we go, that's it. So that one there is a maximum. So I can firm that one up. So we can see what happens to the curve then. There's no other turning points. The only thing that can happen to it is it comes up, turns here, goes back down slightly, turns back there, and then goes back up once more. Doesn't turn anywhere else, so that's what it's got to do. Yeah, so up, around to the local maximum, down to the local minimum, and then back up. And then we can label the curve here, can't we? It was y equals 2x squared minus 3x cubed. There we go. That's number 4 done then. Great. Let's go on to the next one.